Hey friends, welcome back to the channel. Last time we talked about our 2D renderer, which is going to be mostly just for the UI, and did some very basic setup / planning on how we want that to look. Now that I know where that's headed, I'm actually going to backtrack a bit and set up a couple more primitives for the renderer over the next couple videos. So today we're going to be setting up a camera system. Cameras in a rendering context are a little bit different from cameras in a game context, and I'll get into that here in a minute. But anyway, so after this video with cameras, we're also going to have a video setting up transforms and a video setting up a material system and something else that I don't remember. But I'll figure it out. I might make a word there. We'll see. Anyway, cool. So yeah, we're just gonna hop right in to doing camera setup. So let me just get started. Wonderful. All right, so we already have our render stuff here. I'm gonna make a new camera primitive, essentially. And so I've got a couple of things. First of all, I know that I'm going to be storing some positional data in a vector3. So I'm going to bring in the ultraviolet. I guess I should hold on. Before I do that, let's do mod camera and then pub create use camera. There we go. Okay, now it'll actually show me things because I'm in the tree now. Cool. So we're gonna bring in ultraviolet. Let's see. We're gonna need 4x4 matrix. We're gonna need vector3. And I'm probably gonna need, yeah, actually we're gonna go ahead and bring in, what is it, projection? Yeah, thank you. And we want an orthographic, let's actually, I need two of those, because we're gonna go ahead and make the orthographic and the perspective camera, which is a 2D camera, 3D camera. Technically you could reuse those for for a very specific stylistic, like if you want to have a 2D game but in 3D space so you can move the camera and do funky things, like that's an option. And vice versa, if you want to have a 3D game with a 2D camera, that would be interesting. Obviously possible. That would be like a very specific stylistic choice, in my opinion. But anyway, so I know I'm gonna need those things. I don't think I'm gonna need. Well, you know what? We're just gonna start, and we'll see how it goes. So first, we're going to define a camera trait, and the reason for that is that I want to be able to have the camera trait that has the methods, and have the methods work for a 2D camera, 3D camera. If someone who's bringing in the engine library wants to make a different kind of camera with a different with some different stuff, they can also use this trait, and it'll all work out. Okay, so first of all, we're gonna want to let me set up what I want this to look. Actually, you know what? Yeah. Okay, so we're gonna say pub struct camera 2D, and I need a couple of things. First of all, all these things are gonna be private. So first of all, I need a projection matrix, and that's gonna be a mat4. I need a view matrix, also a mat4, and I need the projection view matrix. And the reason that I'm calling it a projection view matrix, you may have also heard a view projection matrix, has to do with the order of operations. So for DirectX, I think when you're doing your projection view world space translations and shaders and things like that, you multiply the view matrix by the projection matrix, and it has to be in that order because matrix multiplication does not have the commutative property where it is the same on both sides. That stumped me for like a week when I was first learning graphic stuff. Anyway, we also want to have a position. That's where we're going to bring in the vector 3. And then I'm going to do rotation also as a vector 3. So here's the thing with that, though, is that the rotation on a 2D camera, like an orthographic camera, really only makes sense if you're rotating it around the z-axis, which is the one coming out of the screen at your face. And so that's when the camera does one of these like wobbles. Turning the camera this way or this way doesn't really make sense for an orthographic camera because you're not going to see anything differently because it's orthographic. Or I guess you would technically see things differently, but I don't know. I may revisit this, but for now we're only going to be rotating around the z-axis. However, for the sake of consistency, because we're also going to have a camera 3D, for the sake of consistency, whoops. Nope. There we go. We're going to have both of those there. And so what I need are some functions that are going to function essentially as getters and setters. But first, the most important function is we're going to have one to recalculate the matrices. And what that's going to do is that's going to take all of the internal data that it has, the position, the rotation, the projection matrix, all of those things, and it's going to recalculate our view and our projection view matrices. So that I'm going to declare that one first because that's kind of the important one. Everything else is just going to be a getter and a setter. So, man, it's hard to type and talk at the same time. Anyway, we're going to say function get position, which is going to take a self. This also needs to take a self. That one actually needs to be, needs to be mutable. And that's going to return a vec3. Then we have function set position. Actually, this needs to return a reference. That's going to take a mutable self and a vec3. Okay, function get rotation. Self is also going to return a vec3 reference. Oops. And then function, I don't know why it's being weird there with the highlighting. Set rotation with a mutable self and another vec3. And again, for the 2D version of this, we're only going to use the z value on that vector for the rotation, and that's fine. That's kind of the plan. Okay, and then we've got a function externally. So the reason I have getters and setters here, because all the math we're going to need to do, we can do internally in the implementation of this trait on both of those structs, because it has itself. It's operating on itself, so it can access all the private things. It's fine. These are for interacting with the camera outside of the camera. So if I want to like have the camera move, then I need to be able to set the position of the camera externally. And so that's essentially what's going on here. And then I don't need to set the view or the projection view matrix. I only need to get them. And so, excuse me. So for getting them, we are going to just say get view matrix. That's going to be a map for reference and get projection view matrix, same thing, self, whoops, nope. There we go. Okay, why is it angry with me here? Oh, I'm sorry. Rotation. And that's why it's angry. Cool. All right, so there's our trait. We've got our structs. Before I do anything else, what I want to do is implement a new method for both of those structs that's going to be outside of the thing, because they're going to take different arguments, and Rust does not allow overloading of functions, which is fine. Cool, so we're going to say implement camera 2D, and all I'm going to do is pub function new, and let's see, camera 2D is going to take a left, a right, a bottom, and a top, and it's going to return self. Okay, cool. And then all I'm going to do is, let's see, we're going to say let projection matrix equal orthographic, because we were here. And we do our left, our right, our bottom, and our top. We also need the near plane and the far plane. I think that this sets both of those to 1. If you don't change it. Like there's actually I guess I'm thinking of like regular OpenGL, not Rust OpenGL, because there's no overloading. But anyway. So we're going to set -1 for the near plane and 1 for the far plane. Is that right? Or does it need to be the other way around? I can never remember. Let me double check that 1 second. Camera 2D. Cool. Okay. All right. I have notes this time. Yeah. Alright, so that's our projection matrix. We're going to let our view matrix is going to start out as map for identity. Oops. And then we're just going to do a camera 2D. And it gets a, what's our first? Projection matrix is the PM. Our view matrix is the VM. Our projection view matrix, and this is why I have it projection view, is so I can remember that it's PM times VM. And then our position is going to be vec3 0. And oops, that needs to not be a semicolon. And same for the rotation. Cool. And then that's just going to return there because I haven't ended that with a semicolon. Beautiful. And then we're going to do the same thing for the camera 3D. Pub function new. I do not remember what the parameters are here, but luckily I can cheat because I do perspective GL. Boom. Field of view, aspect ratio, near plane, far plane. So field of view, aspect ratio, oops, show, near plane, far plane. And then here, we're going to say field of view, aspect ratio, and then near plane and far plane. Great. Same thing for all of the rest of this, I believe. Map for identity. And then we're camera 3D, projection matrix, view matrix. Projection view matrix is PM times VM. position. Why don't I just do this? And boom. There we go. And that sets that up. Great. Okay, so now we have the basics of creating these. Our next step then is just going to be to implement these functions. So I'm actually going to not implement them in the same order that I defined them, just because that I'm going to do the easy ones first. And that's fine. Cool. So we're going to do implement camera for 2D. Boom. Let's bring that up here. Great. So we have function. Oops, it did not fill it in for me. That was weird. Matrices. That needs to be a mutable self. We're not going to implement that one just yet, and then we're going to do the rest of them. So why is it not filling them in? That's so odd. Self to a vector3 reference, and it's just going to be self.position. Boom. And we're going to, oops. Let's go set. And then here. And then that becomes a set. This needs to be a rotation. And then this position vec3, and we'll delete that. And then, oops, equals position. And then same thing here. This needs to be mutable. And then rotation is going to be a vec3. And then equals rotation. Rotation. Did I type that wrong a minute ago? Interesting. And then finally we get function get. Why are you not filling in for me? Get view matrix for the self. Map 4, and it's just reference self dot view matrix. Nope, not like that. And then get projection view matrix. Phew. Self, same deal. Self dot projection view matrix. Boom. Okay, so that's everything there. And luckily, we actually get to, essentially for everything, I think, we get to reuse all of that, with the exception of recalculating the matrices. That might be different. Let me confer with my notes here. I don't know. We're gonna just write this function though. All right, so we got a couple of things that we need to do first. So first of all, we're going to say, we're gonna make a transform that is gonna be a map4, and that's gonna, whoops, damn it. There we go. Identity, and then we're going to translate it by our position. Okay, then we're going to, why is that angry? Conflicting implementation of trait, render, parameters here. I don't know, it's angry at me at the moment. Oh, it would be because this needs to be 3D. And I've put that in the wrong spot. I want to do 2D first. Not that it really matters, I guess. Anyway, but yeah, so then we're going to do the transform, same thing. Oh, I misspelled that. Equal transform times Mat for, there we go, dot from. So this is the 2D camera. So we're only going to be rotating around the z-axis. So we're doing from rotation z. There we go. So essentially what we've done here, for anyone not familiar with Rust, is we're setting the transform. Technically that's immutable. What I'm doing is redefining it here, and so essentially I can use that value, I can redefine it. I'm not actually manipulating this value. I'm like, this is a new variable that just happens to have the same name, which can be kind of confusing, but in this case, and in cases where you have to do like sequential operations and you want to clean them up a little bit, this I think is a great approach. Anyway, so that's our transformation matrix. And so our view matrix is just going to be that transform inversed. So in the Rust version here, the inversed returns the value. Inverse does an in-place change and does not return the value. So we're going to do inversed there, and then self.projection view matrix equals self.projection matrix times self.view matrix. Boom. And so that's going to be mostly the same for this other one, with the exception that instead of doing from rotation z, what we're going to do is mat for from Euler angles, and then we can just say, let's see, our role is z-axis, so self.rotation.z. Our pitch is around the x-axis, so self.rotation.x, and then self.rotation.y for the yaw, if I could spell. Boom. And that is essentially it, I believe. Let me double check and make sure I'm not missing anything. Doesn't really seem like it. Okay, so before I actually incorporate this, let's just cargo run and see what happens. And I have no triangle. What did I do to my triangle? I'm going to pause the recording really quick and figure out what I did with my triangle. Okay, I'm back. Just had an issue in the shader, but now if I cargo run, you can see that that works, and the triangle's back. Great. So essentially what I want to do here is we're going to go here into the renderer, and we're going to do use primitives camera. I need camera. We're just going to say star. And we can just remove those. Why not? Boom. Okay. So here we're going to say our pub cam is going to be a camera 2D. And we're going to say let cam cool camera 2D new. Okay, so here's a thing that has been bugging me and that I'm going to fix right now, which is that I've defined this triangle, but it's being stretched because of our aspect ratio. And so what you can do, cool thing about cameras, and I'm actually, before I finish this video, going to talk about no, probably not. I was going to say the difference between a camera in the like low-level rendering sense and a camera in like the game sense. They're similar, they're not the same. I will go into that at some point over the course of the development of this engine, I'm sure. I don't think I'm going to do it now because that's going to make the video even longer. Anyway, okay, so I'm going to fix the aspect ratio right now, and we're going to say -1 point, if I could type, 1.6, 1.6, 0.9, That's negative. We're gonna say 0.9 and then 0.9. Okay. I hope I don't have that backwards. But anyway, so yeah, we're gonna go down here. I don't need to do anything because I'm already recalculating the thing. I'm calculating the initial state of everything in the new function. And so then what we're gonna do is we're going to provide self.cam here. And actually, no, so we're gonna say self.cam.recalculate. We're gonna tell it to recalculate here, and then here we're instead gonna do self.cam.get projection view matrix. Okay, so it's mad about that. That's because I don't have this set up for this just yet. We're gonna use ultraviolet mat 4, and then down, whoops, wrong way. Here we're gonna say transform. We're gonna say view projection view matrix, which is going to be a mat 4 reference. Boom. Okay, so here is our next task. I guess, is I need a way to, in the shader, to let the shader know where the camera is, what this view projection view matrix is. And the way that we're going to do that is with a uniform. So if you're not aware, a uniform is essentially a value outside of the vertex buffer that holds all of your vertices and things. It's a value you can provide to your shader through the graphics card, through OpenGL. We're gonna set up that ability now, which means we go into the shader program, and down here we're going to make a pub unsafe function of set uniform, and there are a bunch of different uniforms that you can set, so we're going to say mat 4 here, and we need our self. We also need a name for the uniform, which is going to be the string constant here, and we need the value, which is going to be a mat 4 reference. And so we got a couple of things that we need to do. First off, we need to use ultraviolet mat 4. Okay, so here we're gonna say, first of all, we need to get the matrix location, and that is going to be GL get uniform location. Here, our program is going to be self.id, and the name here needs to be a C string, which is not fun, but that's fine. So the thing about the str, the string constants in Rust, is that they are not terminated with a null character, but they are terminated with a null character in C and C++, and this GL library is just like a very thin wrapper around the C OpenGL bindings. And so what I need to do is I need to give it a null terminated string. So what we're gonna do is actually, I made a macro for this, so we're gonna add this in, and then go back down here, and we're gonna say let's say let uniform name equal C string on our name dot as pointer dot cast, and that's gonna get us the uniform name there. Okay, no errors, great. Okay, and so now that we've got the uniform location, that's basically just going to give us a pointer to where on the graphics card memory that location is, where that uniform sits inside of this shader. And then we're just going to GL uniform matrix for FV, right? Yes. Boom. I am awesome. So we're going to pass it our matrix location. We're only giving it one matrix. So the transform is asking if the matrix that we are using is a column major matrix or a row major matrix. And what that means is generally matrices are two-dimensional arrays. And so a column matrix, major matrix, is an array of columns. And a row major is an array of rows. Obviously, like, you have to know which one you have. Both OpenGL and the ultraviolet library that I'm using for the matrices are column major. And so that means I do not need to transpose, so I can say GL false here. And then, was there one more? Yes. Our value here then is going to be our, what, value as pointer. That ought to do that. Great. Okay, so now let's go back here, and we're gonna say shader dot set uniform. So the name that I'm going to give this is projection view. Yeah, we'll say proj view mat, just like that. Great. And I am going to give it that value. Cool. And then we're also going to just space those out a little bit. That's fine. And so then I just need to have the shader. So I have a smaller window here. And so what we're going to do is say uniform proj. Do I need to say mat4? I don't remember. 1 second. I say mat4 proj view mat. And then here we're just going to do our proj view mat times our position. Cool. And so that should let us get that set up. Okay, so we have our shader. Our uniform is being set. We're calculating that properly. Theoretically, at this point, if I just run, I should still not see the triangle for some reason. Okay, let's figure that out really quick. I will be right back. Okay, that was a fast fix. So for some reason, setting the using a separate variable here seemed to be an issue. I think it has to do with cast. To be honest with you, I'm not 100% sure how cast works. I really need to look into that. I just know that it seems to fix pointer issues in Rust for me when I'm messing with OpenGL. Anyway, okay, so if I run now, cargo run, boom, I have a triangle, and you can see that it is no longer fat. It is set up here. If I go here, let's say I do self.cam.setPosition. I wish I could spell. Position. There we go. Vec3, and I want to say, let's do x 0.2, y 0.2, z of 0. Oop. I don't have a vec3 here. That's fine. So we'll just come down here and use ultraviolet vec3. Great. Let's do cargo run now. And boom, the triangle has moved from where it was. Oops, I just tried to type clear there. Not sure if you guys caught that or not. However, now let's say I want to do set rotation. And so we know that we're only using Z here. So what I'm going to do is say X0, Y0, and then Z, we're going to say like 0.5. And now the triangle should be upside down. I don't know if this is I don't know if this is in radians or if it's like 1.0 is a full rotation. So we're going to find out together. Woo! Cargo run. It is in radians, I think. Jesus, I don't know. Yeah, because isn't the red normally at the top? I don't know. Anyway, it rotated, so that's cool. Yeah, cool. So that is pretty much it for this video. You know what, I am going to do one thing real quick that I've been meaning to do. You guys get a nice little bonus. We're gonna start a render command thing. So we're gonna say, oops, mod command and pub create use command star. And then here, all I'm gonna do is xturn create GL. And yeah, I just am going to define a couple of very, very simple render commands. And by that, I mean it's literally just going to be a function. So pub create unsafe function. We're going to say set clear color because I don't like the black background. And then we're just going to get an R value, a G value, oops, a blue, and an alpha. I don't actually know if the alpha works on the clear, like if I could make a translucent one. I mean, like my compositor makes transparent windows, but I don't know if I can make a transparent window without the compositor. Anyway, so this we're just gonna say GL set clear. I wish I could set clear color, right? No, it's just GL clear color. Color RGBA. And then we're gonna do another one. Unsafe function for clearing. And we're gonna say GL clear. And we want to do the color buffer bit. Boom. Cool. And so then down here, what I want to do is each frame, we're going to say command set clear color. And we're just going to do like a gray. Right? We're going to say 0.3, 0.3, 0.3, and 1. Oh, it doesn't like that? Interesting. Okay, so that's the first time that I've actually tried that there, and then we're going to say command clear. And in the future, I may actually have this take the specific bits that we want to clear. So I would pass in like the depth buffer bit, the color buffer bit, that kind of thing. But yeah, so now if I cargo run, then boom, we have a pretty gray. I mean, it's gray. It's just, It's gray. Anyway, it's not black. I love it. Okay, cool. So that is pretty much it for this video. I think next time we're gonna do transforms because we need to, so we've already got sort of a transform on the camera. It has a position and a rotation, but what I'm going to do is I'm going to set up a transform struct that in the future, when I implement an entity component system, is going to let me set up a transform component, because it's basically just going to be like that struct being stored. That's one of the beautiful things about Rust and how it separates data and implementations. I love that. And it makes making an entity component system very, very natural. So yeah, that is pretty much all I've got for this video. Next time, like I said, we're going to be doing transforms. After that, we'll probably do a material system. I may loop in like time steps with the transforms, because those two combine to let you move things around pretty fluidly, and that's nice. So we'll see about that, kind of like I just like last minute put render commands in this video. But yeah, that's pretty much it. I hope you guys enjoyed this video, and I will catch you next time. Bye.